Today we're going to talk about infiltration testing and how to perform this test for permeable pavement. So the first thing I want to mention is that to have a successful permeable pavement system, you need to have a few qualities in the system. The first being it needs to be practical, meaning that from a manufacturing sense, affordability, installation-wise, you need to be able to put these in and make it easy for users. Second, it needs to be accessible. I think we'd all agree that going across the pavement, you need to be able to easily navigate that without tripping or falling. Third, it needs to be functional, both structural and from a stormwater system standpoint. So you got to be able to drive heavy-duty equipment across the surface while still allowing a maximum amount of water to flow through those joint openings. The third thing it must be is maintainable, both preventative and restorative. If you can't do the restorative, then it's not going to last a very long time. And lastly, it needs to be measurable. You need to be accurately able to gauge the performance at any given time. And so that's where we're going to pick up today and talk about that. Why is measurable important? Because it benchmarks the system performance and how fast that water can flow off the surface. It also establishes the effectiveness of a maintenance program. So if you don't have anything in place, either it's going to clog up quicker. If you do have some maintenance in there, you can tell whether it's going to perform over a long period of time or not. It also provides the overseeing jurisdiction assurances that the system's going to function properly. So your local municipality may want to check out how fast the water is flowing off the surface to see if it's draining onto other properties, and so they need to be able to gauge that. And lastly, it predicts infiltration longevity, which we'll talk about later and how to do that. So with the test procedure we're going to go through today, we're looking at the ASTM C1781. That's by the American Society of Testing and Materials. It's the standard test method for surface infiltration rate for permeable unit pavement systems. And this gives you a procedure on how to do that so that everyone does it the same way. So there's really three components to it. There's a pre-wetting stage where we're going to put a small amount of water on the surface just to calculate to see how we're going to test it. Then we're going to do a full testing where we're going to either pour 8 more pounds of water on the surface or we're going to pour 40 pounds of water on the surface. And the last part, we're going to gather that information, the data that we collect during the infiltration testing, and we're going to run that through calculations to get our infiltration rate. Now there's some equipment that you're going to need, and we'll talk about that when we get out to the field there to do the testing. We're going to need an open-ended infiltration ring. This could be metal or plastic, so you could make one of these yourselves with a 5-gallon bucket. The diameter needs to be about 12 inches and only needs to be about 2 inches tall. And then you're going to put a mark on it at the 10 and 15 millimeter line. So you have a spot to gauge where to pour the water when you're doing the test. You're also going to need some plumber's putty. Now this you can pick up at any local hardware store. This will run you a couple dollars for a jar of that. And then you're going to need some water source. So you want to have clean water to pour into the ring to see it drain into between the pavers. And lastly, you're going to need a timer to time to see how long it takes for that water to drain into those paver areas. Now, before we get out to the side, I just kind of want to show you what this is going to look like. So we're going to put this ring down, we'll put the putty around it, and then we're going to pour the water in the surface. Here's a couple examples of the ring setting on top of the surface. Now, when we pour the water, we want to shoot for the center of the ring, and we want to pour it onto the paver area, not directly into the joint, so the water will distribute a little bit better. And as we head out there here in a few minutes, this is our entire infiltration plot at Unilock in Aurora, Illinois. And so the idea behind this was to test the initial infiltration rates and then test these over a period of time so we can see if there is any decline in performance over 2, 5, 10-year period and so on, and continue to test that, and so we can plot this out to see what the longevity of it is. Now this has been installed for about 4 years now, and we've tested it at least 2 times, and we'll go out there right now and try it out. Welcome to the Unilock test plot area. This is where we do our infiltration testing. Now first I want to talk about the equipment I mentioned in the PowerPoint presentation. This is our infiltration ring. You can see we took a 5-gallon bucket and we cut off the bottom 3 or 4 inches here to create our ring. Now we've pre-marked this with the 10 and 15 millimeter lines. These are our fill lines required by the test method. So we want to try to maintain the water level between these two lines if possible. Most of the tests we've done, the water rarely gets up to that first line because it drains so quickly. The second thing we have is our plumber's putty. Now this material can be picked up at any hardware store for a couple $, and we're going to use this material to seal up the ring around the paver area. And then the last thing we have is our 5-gallon bucket. Now we've pre-marked this for our 8-pound water line and our 40-pound water line. Makes it a little bit quicker when you're out there in the field trying to do this test. So you don't have to weigh it each time. So we've pre-weighed this area. And the last thing I mentioned is you really need to record this information. So have a piece of paper you can write down the times that it takes to drain this material. So we're first going to start by putting down the ring across the surface and applying our plumber's putty. All right, now that we've sealed up around the outside of the ring, we can start doing our pour test. Now we're going to start off with 8 pounds of water. We're going to pour this into the ring, and we're going to time it to see how long it takes for that 8 pounds of water to infiltrate. So pull up our timer here, and as soon as the water hits the surface of the paver, then we're going to start to time this draining.
1, 2.
1, 2, 3. Now sometimes you might experience some bleed out where the water will drain out. It shouldn't be too critical, like we see some here on this side. It's still draining through the pavement very quickly. And stop. It took 25 seconds for the 8 pounds of water to drain through the surface. So now we're going to wait 2 minutes for this to drain, and then we're going to pour 40 pounds of water on the surface since it drained less than 30 seconds. So I'll start my timer here for the 2 minutes.
This is all going to be
All right, now that our 2 minutes is up, we're going to pour the 40 pounds of water, and I'll start the timer once the water hits the surface of the pavers. As soon as the water stops draining, I'm going to stop my stopwatch, which is now 1 minute, 39 seconds for the entire 40 pounds of water to drain through the surface. So write down at 140 on my sheet here, 139. And we'll go back in now and perform the calculations what the maximum infiltration rate is. All right, we're back from the test plot area. So now we got to go to the third stage of this test procedure, and that is doing the calculation. So when we look at the calculation here, we're trying to achieve the I. We're trying to figure out what the infiltration rate is, which is this first one here we're going to calculate. We know the mass of the water. We used both 8 pounds for the pre-wetting and 40 pounds for the test. Now, if your infiltration rate was less than 30 on the pre-wet, or sorry, longer than 30 on the pre-wet, we're going to do another 8 pounds. We also know the measurement of the diameter of the ring. So in this case, the plastic ring that I used for the 5-gallon bucket is about 11 3/8 inches. And they know the timing of it. We timed that area of the infiltration, took 1 minute 39 seconds. So we're going to plug that into our equation. And then we're given this amount. This number here is the amount of of inches per pound of water it takes to flow through that area. Now, if we go to the next slide here and we look at the results worksheet, this is for a project we've already done testing on. And I just want to show you that if you're doing multiple areas, it's good to have the spreadsheet there so you can write down the time. Now, I have this set up so that you can plug in the both minutes and seconds, and then it's going to calculate the seconds for the equation, which makes it a little bit easier. Now, if we drill down on this and look at the actual formula, I've taken that formula from the test procedures and plugged it into the Excel spreadsheet. So you can see the cells that are highlighted here are the different parts of the equation that we need to complete. And we know that based on the 139, it took the maximum infiltration rate of the test we did today would be 396 inches per hour. So what do we do with that information once we have it? Now, luckily, Unilock's gone through, and because we've had this test plot out there, we've actually calculated all the infiltration rates for all the different sites on there. So we have a benchmark for the initial infiltration test. And that can be shown over here in this column on the right. And that gives you a better idea of where to start with in terms of your maintenance program. Now, what are the next steps? The first thing we want to do is calculate that minimal infiltration rate. To do that, we need a few things. We need to find the 5-minute infiltration rate for a 100-year rainfall for your area. And I suggest doing the 2-year, the 10-year, and the 100-year event. So that's going to be for 5 minutes. The second thing you want to do is divide that by the void space ratio. So, for example, here, if we're looking at a 5-minute 10-year intensity for Illinois, it's about 6.48 inches per hour. And if we use the town hall paver with an infiltration void space ratio of 6.5%, that computes out to just under 100 inches per hour for that 5-minute intensity of 6.48 inches per hour. Now, that might seem like a little bit too much, so we've actually done all the calculations for you for kind of common storms throughout the Midwest. The 2, the 10, and 100 year are listed here at the top at the 4.5 inch, the 6.5 inch, and the 11 inch rainfall amounts there. Okay, so the next part of this, we want to calculate the minimum infiltration rates. So we've taken our numbers from our test plot area and we've plugged it into our formulas here for that 5-minute intensity for the 2, the 10, and the 100-year rainfall event. So let's go back down and look at this town hall paver at 6.5 inches, 6.5% infiltration void space ratio. So if we look across the top here, we have the 2-year at 4.5, the 10 at 6.5, and the 100-year at 11-inch rainfalls. So if we look at this 10-year rainfall event for that 5-minute intensity, you're going to have about a minimum amount of water that flows through that is 100 inches per hour. So if that infiltration rate drops below 100 inches per hour, you're going to start to generate runoff to other areas. So this is why the infiltration rate, knowing what it is very important. So then what we can do with that information is we can plug it into a spreadsheet and create a chart like this. And this is going to help document what our rainfall minimum amounts are for those 2, 10, and 100-year events. So if you look down here across the bottom, you'll notice that there are 3 lines here that show the 100-year rainfall event at 151 inches. The yellow line is at 89 inches per hour, and the last bottom line is 62 inches per hour. So by plugging those numbers in, you can start to generate a chart that actually will help you with your maintenance program for permeable pavement. So we want to make that useful by charting that information, use it to calculate those 2, 10, and 100-year events, and then benchmark restorative cleanings as you go. And you can see on the chart here, we actually have, we're showing a theoretical benchmark of a restorative cleaning and how this extends that longevity of the system. If you have any questions, please reach out to your local territory manager or commercial rep, and we'd be happy to answer your questions and help you with your infiltration testing. Thank you and have a great day.